Subscribe and press the bell icon to never miss a video from 2IITians. We are going to study collinearity now. What is collinearity? We will prove 3 points as collinear, and there are various methods to do it. Okay, 3 points A, B and C are to be collinear. Then we will use 5 methods. What are those methods? The first method is using distance formula. What we will prove? We will say that AB plus BC is equal to AC. This is trying to prove this 3 points A, B and C as collinear using distance formula. Collinearity means that we are going to prove 3 points are in the same line. 3 points, 3 or more, we can even go for 4 or 5 points, but here we are using only 3 points. 2 points are always collinear. After 3 or more points, we will have to check whether they are collinear or not. 3 points are in the same line. This means that the 3 points are collinear and collinearity is true for those 3 points. Okay, so don't get confused between collinearity and collinear. They are almost the same things. Okay. Distance formula is first method. Second method will be section formula. Here we will try to use some ratio k:1. We will assume a ratio on our own and then we will prove that k:1 ratio holds both for abscissa and ordinate of the point B, whichever lies in between. Okay, this is using section formula. Distance formula is very clear, but in section formula you will need an example to appreciate it more, that how section formula can prove collinearity. Okay, the third method is slope method. Slope, or some people call it gradient method. Okay, here we will prove that M1 is equal to M2, where M1 is slope of AB and M2 is slope of BC. So if both the slopes are equal and B is a common point, then certainly ABC must be lying in the same line. Okay, so third method we have discussed now. Let us come to the fourth and fifth. Now the fourth method. I wanted all the methods to come in the same screenshot. The fourth method is equation of straight line. Equation of straight line. Okay, what we will do here, we will find out the equation of the line AC and satisfy the point B on the straight line AC. If it satisfies, then it means that A, B and C are on the same line. Okay, so the strategy here will be satisfy point B in the line AC. We can also do this. We can calculate the line AB and satisfy C there. We can calculate the line BC and satisfy A there. It is equally probable. Okay. So the fourth method is satisfying a point in the line made by the other 2 points. Okay. And the fifth one is not very interesting. Here we have to learn a very big formula. Area of triangle ABC, we will have to prove 0. What is the formula? Half modulus of x1 bracket x2 bracket x3 bracket, and this all should come to 0. And what we will fill in the brackets, we will learn by this circle 1, 2, 3. We will go clockwise. After 1 we have 2 and 3. So y2 minus y3. After 2 we have 3 and 1. y3 minus y1. After 3 we have 1 and 2. So y1 minus y2. Here we will have to prove that the area of the triangle is 0. And remember that what are x1 and x2? x1 and x2, x1 y1, x2 y2, x3 y3 are the coordinates of the 3 given points A, B and C. Now we will use all these 5 techniques to prove collinearity using the same example. So we will solve the same question 5 times using these 5 methods. Okay, so hold on. Using distance formula, check whether A, B, C are collinear. So what we will do, we will write the 3 points, minus 1, 3, B 0, 2 and C 1, 1. And we can calculate AB, BC and AC as distances. First of all, we should know the distance formula. Distance formula between any 2 points is given by, suppose the distance is PQ, it is given by x2 minus x1 whole square plus y2 minus y1 whole square. Here x1, y1 and x2, y2 are the 2 concerned points between which we are trying to calculate the distance. So how we will calculate the distance AB? And we have to take care of the signs too. Okay, x2 is 2. X2 is 0. X2 is 0, 0 minus 1. Here what you can write is x1 y1, x2 y2 if you are a beginner. Okay, 0 minus 1 plus 2 minus 3 whole square. So AB comes out to be minus 1 minus with a minus sign becomes plus 1 square plus minus 1 square. So this is 1 and this also becomes 1. So AB is root 2. Now we have a little space here. BC. How to calculate BC? The same formula will apply. This time I will consider that this is x1 y1 and this is x2 y2. Okay. So 1 minus 0 whole square plus 1 minus 2 whole square. Again we have a similar situation. This again becomes root 2. So fortunately these 2 distances come out to be equal. So this means that point B is the midpoint of AC. But this will not be the case for always. So this is no result, okay? All we have to do is now calculate AC and check whether AC becomes the sum of AB and BC or not. Okay, so AC is, again I will write x1 y1 here. So x2 minus x1, this will become 1 minus minus 1 whole square plus 1 minus 3 whole square. This comes out to be 2 square plus minus 2 square. This is 4, this is 4. Now we have a under root 8. Under root 8. You can write it as 2 into 2 into 2, and so this becomes 2 root 2. Root 2 units, root 2 units, and 2 root 2 units. Hence we can say that AB plus BC LHS is equal to AB plus BC. AB is root 2, BC is root 2, this is 2 root 2, and 2 root 2 is equal to AC. So RHS. Therefore, AB plus BC is the LHS and AC is the RHS. Hence, point B lies in AC. Therefore, points A, B and C are collinear. So this is the first method. Now we will use section formula. So let us assume that B already lies in the line segment AC and B divides the line segment AC in the ratio K is to 1. So this should be confirmed both with the abscissa 0 and the ordinate 2. So what we will do, that we will calculate the same value of K for both these X and Y coordinates. Okay. So we will write let 0, 2 divides the line segment AC in the ratio K is to 1. Therefore, bisection formula, we will write this as point B. Bisection formula, the coordinates of point B will be given by, do you know the formula M1 x2? We will employ K here. In the denominator we will get K plus 1 and K x2 plus 1 multiplied by x1. So it will become x1 itself. And here we will get K y2 plus y1 divided by K plus 1. This itself is a form of section formula. Okay, so using this equation we will get one value of K. We should get the same value of K using this equation. Equating abscissa. So 0 is equal to K. What is the value of x2 here? Okay. The value of x2 here is 1. The value of x1 is minus 1. So this implies K minus 1 divided by K plus 1 is equal to 0. Equating ordinate. So here 2 is equal to, we can write K plus 1 here, we can write K bracket and whatever is y1. Okay, so y2 is 1 and y1 is 3. So here nothing new has to be done. K minus 1 is here and this brings K is equal to 1. So here also K is equal to 1 should come If everything is true, 2k plus 2 is equal to k plus 3. We have multiplied k plus 1 on the left hand side, and 2k minus k will become k, 3 minus 2 will become 1. So great, we have got k is equal to 1 from both the sides. So we will write something here. Therefore, the point B 0,2 divides the line segment AC in the ratio 1:1. We had assumed k is to 1, value of k is 1, it is confirmed twice, so the ratio is 1:1. It is confirmed for both abscissa and ordinate of point B. So we can say therefore points A, B and C are collinear. So this was the method 2. Using slope or gradient, check whether A, B, C are collinear. Personally, I would say, and I think most of the mathematics students and teachers will agree with me here, that the slope method is the easiest and the fastest method of checking collinearity. So we will see it here. Okay. Directly I am writing slope of AB, slope of BC. Some people and some books also confirm the slope of AC also, but I believe that confirming the slope thrice is redundant. You just have to confirm any two slopes, ABBC or ABAC or BCAC, any two combinations you can, any combination of two line segments you can check. So M1, let us assume that the slope of line segment AB is M1, the slope of line segment BC is M2. Don't think that M1 is to M2 is some kind of ratio. Here we are dealing with the gradient or slope and the symbol is M. Okay, so M1 is Y2 minus Y1 divided by X2 minus X1. Remember, this time this is X1 Y1, this will become X2 Y2. And again M2 will be calculated by the same formula, Y2 minus Y1, X2 minus X1. We will calculate it later. Let us deal with AB first. Okay, so what is Y2? Y2 is 2, Y1 is 3, X2 is 0 and X1 is minus 1. Minus 1, 0 plus 1 is plus 1, so this gives us minus 1. Again M2. This time we will shift. This is X1 Y1 and this is X2 Y2. Okay, Y2 minus Y1. This will become 1 minus 2, X2 minus X1. This will become 1 minus 0. This is minus 1 divided by 1, again minus 1. So the slopes M1 and M2 are equal. So somebody can argue that this line is parallel to this line having the same slope, M1 is equal to M2, is perfectly correct. But not only they are parallel, they are on the same line because point B is the common point. So this is the logic here. So M1 is equal to M2, we have written here AB is parallel to BC, but point B is common to AB and BC, therefore ABC is a straight line, and we conclude that points AB and C are collinear. Using equation of line, check whether ABC are collinear. Now we will use the equation of straight line AC and then satisfy the point B. Equation of straight line AC will be y minus y1 is equal to m into x minus x1. And how we will calculate m? We will write x2 minus y2 minus y1 divided by x2 minus x1. X minus x1. Where are the x1 and x2, y1 and y2? This is x1, y1, this is x2, y2. Okay. So let us choose this point. This looks better. And so this way what will happen, that this will become x2, y2 and this will become x1, y1. Nothing very special about it. This is only to tell you that these orders don't matter. You can assume any of the points as x1, y1 and as x2, y2. It is totally on your own free choice. Okay. Why I did that, I switched these x1, y1 and x2, y2 is because these values are simpler as compared to these. However, we cannot escape these values. Okay, here we will use them. Okay, so 1, x1, y1 are here, minus 1, minus 1. What is y2? y2 is 3. And what is x2? x2 is minus 1. So we are here, y minus 1, 3 minus 1 is 2, this is minus 2. And this is x minus 1 minus 2y plus 2 is equal to 2x minus 2. Okay, or you could have reduced everything. Y minus 1, this is minus 1, x minus 1. This is y minus 1 minus x plus 1. So x plus y is equal to 2. So this is the equation, and now we will satisfy. Okay. B0, 2 in the line. We are just checking. Okay. Checking that B0, 2 lies in the line x plus y is equal to 2 or not. Okay. LHS is equal to x plus y. What is the x coordinate? 0. What is the y coordinate? 2. This is 2, which is itself the RHS. Okay. So we can now say that point B0, 2 satisfies the straight line AC, which the equation we have already calculated as x plus y is equal to 2, and therefore A, B and C all lie in the same line, and the equation is this. Thus we will say A, B and C are all collinear. Using area of triangle, check whether these 3 points are collinear or not. So first of all, what we will assume that these 3 points are not collinear and they form a triangle, and we will try to find out the area of the triangle. If the area of triangle is something positive or negative, then we will say that the triangle does exist and the 3 points are not collinear. Otherwise, if the area of triangle comes out to be 0, there is no area. What will happen if there is no area? Then this point B will keep falling down until no triangle at all is formed and ABC form a straight line. So here the goal will be to prove that the area of the triangle is 0. Okay, so let me write the large formula. Area of triangle is half modulus of this quantity. Modulus avoids the confusion of positive and negative. All the answer will come either positive or they will come 0. Here we are interested in 0. Okay, so let me write what is x1. x1 is minus 1. x2 is 0, very good, nothing to do here. x3 is 1. Okay, so what is y2 minus y1? 2 minus 3. y3 minus y1, we don't need to do anything here because 0 is guarding outside. 1 minus 3. And y1 minus y2, y1 is 3 minus 1. So everything seems set. Okay, minus 1 multiplied by minus 1 plus 0, and this is 3 minus 1, 2. Okay, there seems to be some mess up. Okay, the mess up I have found out. A student sitting here has just told me that x1 y2 minus y3 is the correct formula. Okay, so again we will plug in the values. 0 was here and x1 is minus 1 and x3 is 1. y2 minus y3, 2 minus 1. Now we are going in the right direction. y3 minus y1, this is 1 minus 3. So that is why I told you that this is a boring method. y1 minus y2, 3 minus 2. This time we are doing it in the right direction. 2 minus 1 is 1 again. y2 minus y3, y2 minus y3, 2 minus 1. So we will write everything right here. Minus 1 multiplied by 1, 0, 1 multiplied by 1. So this is minus 1, 0 will vanish away, plus 1. 1 modulus of minus 1 plus 1 is 0. So 1 by 2 multiplied by 0, this is 0. Since the area of triangle is 0, area of triangle ABC is equal to 0. Therefore, points A, B and C are collinear. So this area of triangle method is a bit lengthy, and that is why it is most popular in the exams. So all the 5 methods are covered now.